Okay? So graphing systems of inequalities. It's same as with before, guys. Same, all the rules apply except for you have multiple inequalities. Page 29. Multiple inequalities on the same pane. I would say work with each one separately and then just draw them on the same plane. And this is why, guys, I use reverse shading. If you were to graph all of these inequalities and shade them correctly, like using regular shading, look at that. You got to find the one solution region that is true for all of them. And it's really hard to kind of figure that out if you are shading. This is a software. I can tell that this is the darkest region, so the solution region is found in there. But we are not as careful as the software, right? Like when we shade, we're like, wait a minute, it's just a scribble. You're like, what's the solution region here? It was a nightmare when I taught it that way. So like, I don't know, 10 years ago, whatever, I'm like, forget that, let's do reverse shading, right? So reverse shading, it ends up being you shade out the false regions for all of them, and then you end up with your solution region unshaded. So it's a lot easier to see, okay? So this is a strategy to find solution region. So I would say, I will remind you, even on the test, if you ask me, should I do reverse or whatever, I will basically say, like, if it's a system, use reverse shading. So this is the solution region. All of this is false, right? False, false. It's false for all the inequalities around. And so basically you end up with the solution region not shaded. So it's a lot easier to find, okay? I'm gonna leave it like that. I'm gonna jump right into the example and talk about corner points tomorrow, okay? So let's go to our next page here, 30. And I actually decided to use the scary textbook version of providing the inequalities. It just says that these are the variables, x and y. This is the inequality that we're interested in. And all real numbers apply. So it's just basically, that's basically for all the examples we've done, this is the case. So all real numbers apply. Same thing here. But these are the inequalities that you really need to focus on. Okay? So this is inequality number 1 and inequality number 2. I encourage you to split them up like that, label them. And let's graph this thing, okay? Let me just get to my solution here. So I will work with inequality. This is where you need to be organized, okay? Inequality 1. I will remind you, clean up at home as well, your room, right? Clean up. Intercepts. Rewrite. This is kind of what you should always have in the back of your head. Clean up, rewrite, intercepts, rewrite. Okay, so for inequality 1, I have this, 4x is greater than 6y plus 12. I don't like this, right? So for now, I'll bring the 6y over to the other side. So 4x minus 6y is greater than 12. I can guarantee you if you had a different teacher teaching this course, they'd probably do it differently, okay? So it's not like when you take a different class somewhere and you're like, wait a minute, I didn't do it that way. It's just one way that I found works best for most students. Bless you. So we've cleaned this up, clean up, and now let's do the intercepts. And this is where I like my table like this, to keep them concisely somewhere where you can easily find them. Remember, when you're finding the x-intercept, y is equal to 0. Okay? So you go for x is equal to 12. Why do you turn to equals all of a sudden, Mr. Dirksen? Like, what's up with that? Because when I do this, I focus on like that boundary line, and the boundary line has an equal sign, right? It's an equation. But instead of rewriting that whole thing with an equal sign, I don't bother with it anymore. So x is equal to 3, 3, 0, which could be a decimal. Okay? Y-intercept, negative 6y is equal to 12, divided by negative 6. Y is equal to negative 2, 0, negative 2 it is. Nice and concise. That is for graphing purposes. Okay? What's the last step? The third is rewrite. So I take the 4x minus 6y is greater than 12. So intercepts. And let's rewrite. Negative 6y. I bring the 4x over to the other side. So it's negative 4x plus 12. And now I must do what? Divide by negative 6. Does that ring a bell? You're hoping the bell is ringing, right? Just about now. When you divide by negatives, what do you have to do? You flip the sign, right? And this is negative divided by negative, which is just positive. You do not need to reduce the fraction. If it bothers you, you go for it. 12 divided by negative 6 is negative 2. This one you're going to need later on if you want to graph this in your calculator, because we're going to find the intersections between all those boundary lines. Today we're not going to bother with it. I just want you to graph. So guys, what can we tell from this, from the symbol itself? This is going to be a dashed line. I know that the true region is below the line. Make sure you get to this point. I want to be clear, because every year I cause major confusion with this. Since we're using reverse shading, where would we shade if the true region is below? Above. So I tell myself, shade above. This is, I want to know this because when you have a bunch of inequalities that you're about to graph, if you don't do this, you're going to mix it up later. Okay, you're going to mix it up in your graphing. Okay, we're done the first inequality. Yay! Let's do the next one. Here, inequality number 2. That one is 3y less than or equal to negative 2x plus 9. Let's clean it up. Meaning, I want the x and the y on the other side. So that's 2x plus 3y is less than or equal to 9. Find the x-intercept and the y-intercept. Two x is equal to 9. Divide both sides by 2. X is equal to 4.5. It's okay to have decimals here. Then we've got 3y is equal to 9. Right? divide both sides by 3, y is equal to 3, so 0, 3 is the intercept. Perfect. I will use my space that I have here to rewrite. I did cleanup. I did the intercepts, and I'm going to rewrite. So I take the 3y, the 2x is coming over to the other side. Subtracting. I divide by 3, positive 3, so I don't need to do anything with the inequality. That's 2/3 x plus 1, because 3 divided by 3 is just 1. Oops, that can't be. This is 3, this is 1, something went wrong, and I see it right away. 9 turned into 3 somehow. So this is supposed to be 9 here. I'm glad it happened, because then, right, it's a reminder, watch out. Okay? That's my inequality that I'm going to need later. Because it's less than, first of all, I know this is a solid line. The true region is below as well. I'm going to shade above. This is the one I want to focus on. Now we're ready to go. Ready to graph. Not go home yet, but graph. I'm going to try to zoom out so we can see everything. So make sure I already gave you the grid. You do the rest, okay? Let's focus on this line first. 3, 0, 0, negative 2. So 3, 0, 0, negative 2. It's a dashed line, okay? Let's graph it. Go from end to end. Okay. Label it. Don't shade yet. Shade at the end, because if you make a mistake, it's going to be very messy. 4.50, that's my other line. 4.5 is right about there. 0.3 is right there. This is a solid line. I expect it to go down because my slope was negative. Isn't that pretty? Y is less than or equal to negative 2/3 x plus 3. We've got both boundary lines in there. And now we shade. Okay, so watch what I do. I go to my first line. I'm ready with my ruler. I told myself to shade above that line. So I go to it. And just lightly, I wouldn't go too crazy there. Just lightly, because even if you go over labels, it's not going to completely block it out, right? There we go. That's all false. Then I take my other line, I go right against it because I'm shading above that one too. I told myself that. So you shade this way. So the one condition I put to students, if you're going to do reverse shading, if we're going to do that, we need to make sure we label our solution region. If we don't do that, we're actually misleading, right? Like we're like, what is the solution up here? Is this it? Because this is the darkest region. It's like, no, we're saying we're saying clearly that that's our solution region. Okay, tomorrow we're going to focus on finding that point of intersection. You actually already know how to do that, but right now I just want you to be able to graph this. So I'm going to ask you to do one more yourselves by tomorrow. So let's go page 31. That's it. Remember, there's special cases. There's vertical lines, horizontal lines. They are there. They're actually a lot easier